We're going to take a look at factoring some special cases, recognizing the difference of squares, a perfect square trinomial, the difference of cubes, and the sum of cubes. So these are specific things you have to recognize. So you have to be able to recognize the difference of squares, and this is how you do it. First of all, it's two terms that are subtracted, and the first and the last term have to be perfect squares. And if that's the case, it factors to x plus y times x minus y. So if I look at p squared minus 100, p squared is a perfect square, it's p times p. 100 is a perfect square, it's 10 times 10. And so I recognize that's the difference of squares. So I'm going to do p plus 10 and p minus 10. So it's like you're taking the square root of the first thing, taking the square root of the second thing, and then you're just using opposite signs. Now in 2x squared minus 18, I see they both have a 2 in common, so I would factor that 2 out. Now that I factor the 2 out, I can see that x squared is a perfect square, 9 is a perfect square, and they're being subtracted from one another, which means I take the square root of x squared, which is x, the square root of 9, which is 3, and I rewrite them as the sum and the difference of that number. Here's some additional ones. Here, you can also factor out. Or you can look at, well, 9 is a perfect square, and so is 16. So if I took the square root of 9a squared, that would be 3a. And if I took the square root of 16b squared, that would be 4b. So I can then write it as the sum and difference. So it doesn't have to just be a term with no coefficient as the first term. It can have a number. Just like in D, I'm squaring n plus 3. 49 is a perfect squared, and so is z. So if I look at that, I would write the sum and difference as m plus 3, because the square root of m plus 3 squared is m plus 3. And then I would be able to combine like terms if possible, and I can't, so that's as far as I can take it. Y to the fourth minus 16, the square root of y to the fourth is y squared. The square root of 16 is 4. So I have two perfect squares, and I'm going to write them as the sum and difference of those. Now, if you look at that, I wind up with y squared minus 4, which is also a perfect square. The square root of y squared is y. The square root of 4 is 2, so I'm actually going to break that out. This is where the lab will catch you, and it's going to tell you didn't fully simplify, and you're going to be like, I simplified, I factored it. Always, always check that final answer to see if you have two perfect squares being subtracted, because it does happen often in the lab. Now, a perfect square trinomial is not as useful, right? So you can get to this same answer by factor by grouping or by regular factoring. It's not unique like the difference of squares is, but let's just take a look at how we can recognize it. So in this equation, I know that 49z squared is a perfect square. I know that 1 is a perfect square. And I know that 2 times 7 times 1 is that middle term. So it's going to factor 2, the square root of the first term minus the square root of the second term. And I'm going to write that as a product as squared. I know that it's subtraction because the middle term is negative. Here I can do the same process. I can see that 9a squared is a perfect square. 64b squared is a perfect square. 2 times 3 times 8 gives me 48. And so I can utilize the formula. I can then look at this next example. X squared is going to be a perfect square. Y squared is going to be a perfect square, but we have to factor by grouping here because I have two middle terms. So when I do that, I'm going to group the first three terms together. And I know that they become x minus 1 squared because x squared is a perfect square, 1 is a perfect square, and 2 times x times 1 is 2. So that's where that's coming from, which you could then distribute the y squared to each term and simplify it. Like I said, these I would really just factor by grouping this. I wouldn't necessarily use these factoring perfect square trinomials just because I don't think they're very instinctual, whereas the other one is more instinctual. Now, the difference of cubes, this is a really important one to know because you cannot factor by grouping to get this answer. It's not going to happen. So you have to recognize the first term is a perfect cube, the second term is a perfect cube, And then it's subtraction, so that you will rewrite it as the cube root of A minus the cube root of B, and then I'm going to have this squared. So let's see it in action. So I have x cubed minus 1,000. X cubed is a perfect cube, 1,000 is a perfect cube, and they're being subtracted. So I can rewrite this as x cubed minus 10 cubed, and I can just simply fill in that formula. So I have x minus 10, and I'm supposed to do x squared plus x times 10 plus 10 squared, which simplifies out to that. Here are some additional perfect cubes. I would rewrite them as their cube factors, and then I'm going to apply the formula to them. Same thing in part C. Rewrite them as their cube factors, and then use the formula to factor them. You have to recognize those. Those will not be recognizable without that formula. The same thing is true for a sum of cubes. The sum of two cube terms does have a factoring shortcut. You're not going to be able to get to this answer unless you know this formula. So if I look at this equation, I'm going to rewrite it as their cube factors and just plug straight into the formula. I'm going to simplify that out, and then I'm going to move to part B. I'm going to rewrite it as the cube factors. 4 cubed is 64, 5 cubed is 125. If you don't know that, use your calculator to your advantage. Plug it in the formula and then simplify it. Same thing here. Write it as your cubes or factor something out. Since I can factor a 2 out, I would definitely factor a 2 out, rewrite it using the formula, and you're done. Here in part D, I'm going to rewrite it as my cubes. I'm going to plug it into the formula, and then I'm going to square it out to get the simple. Now, this is the screen that I wanted to get to. You probably want to take a screenshot of this screen because it has all those formulas we just went over in one place.